Today we are going to be covering section 10.4, hyperbolas. So you should have your essential question written down. And you also received a cutout. All three cutouts will go together. So take some time to write the title. Take some time to write your essential question. And once you're ready, we can start with example number 1. So go ahead and pause it, and we'll come back. So in this case, we are dealing with the definition of a hyperbola. So notice that the definition will look very similar as before. A hyperbola is a set of all points x, y in a plane, but now instead of the sum where it was for the ellipse, now we have the difference of whose distance from two distinct points, which are the foci, is going to be a constant. So now instead of adding them, we're subtracting. We're going to cover this more when, next time I'll see you guys. So therefore, the distance between 2 points, so if I take a line, if I go from my foci anywhere on my hyperbola and go back to my center, if you subtract those two segments, you'll get a constant, and it'll be the same as if you go from your focus anywhere on your hyperbola and back to your center. If you subtract those two segments, you'll be the same. Or if you go from your focus anywhere on your hyperbola and back to your center, if you subtract both segments, it'll be exactly the same. Or if you go from your focus anywhere on your hyperbola and back to your center, if you subtract the distance or those two segments, will be exactly the same. So that's a property of a hyperbola. So notice that once again they give us two different standard forms. See if you can tell the difference. So take a minute and see what is the difference between those two. Correct. So at this point you see that in this case we have your x squared is positive or your y squared is negative. In this case, your y squared is positive or your x squared is negative. So therefore, if your x squared is the first one, or in this case is the positive one, then we know that your hyperbola will be sideways. Your major axis will be the horizontal. And vertical major axis, that means if your y squared is positive, that means that your x squared is negative. So if your y squared is the one that's positive, we usually write down first. It's going to be up and down. We have a vertical major axis. And notice that once again we have the formula to find the value of c. C units from the center, and this is your equation. Now notice that in this case we have a minus in between, so therefore your equation will have a plus. In your ellipse you have a plus, so therefore this was a minus. Now one of the key things that you have to remember is the c is the distance from the center to each focus. And once again we have the definition of once again we have the definition of eccentricity. Eccentricity measures the opening of the branches of the hyperbola, whether they're going to be opening quite a bit or it's going to be a little more narrow. And notice that in this case the value of e will always be greater than 1, where on your ellipses it had to be between 0 and 1. On a hyperbola it's always going to be greater than 1. But let's go through example number 1. So go and write it down. We'll need a graph as well. We'll need a 5x5 graph. So now, if you have Miss Kawahara last year, then you covered this before. If you did not have Miss Kawahara, then this will be the first time that you've seen it. So first, we are going to write down our center. Our center, once again, is H and K. If you notice, in this case, there's no H and there's no K, so it will be 0, 0. Next, I need to be able to find my A value and my B value. In a hyperbola, your A value is always the one with a positive y square. So this will be your A square. This will be B square. So therefore, A will be 5 and B will be 3. And now from your center, under the y, there's a 25, so it'll be 5. It's under the y, so I'm gonna go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Under the x, there's a 9. Square of 9 is 3, so therefore to the right 3, and to the left 3. So very similar to a ellipse. But now the only thing that we're going to do, we are going to get our cross sections. We're going to draw our asymptotes first. So therefore I'm gonna make a box. So I'm going to go under those 2 points and find my corners. And most of the time, we actually take the time to actually build a box. So this was down 5, so therefore my other section is here. And notice that you want to be able to place it in red. You also want to be able to place it as dash, because this is not part of your graph. This is part of the construction. And now that I have my box, I'm going to draw my asymptotes. My asymptotes, I'm going to connect both corners. And I'll place a dash as well. Then I'm going to continue beyond. You want to make sure that you make it as beyond your graph for hyperbolas. Once again, I'm going to connect both corners. Make sure that you go beyond your graph. And we'll come back to the equation of the asymptotes in a few minutes. Next, I need to be able to decide whether my parabola is going to be sideways or it's going to be up and down. So in this case, your y square is the one that's being positive, so therefore your hyperbola will be up and down. So therefore, from your vertex, you're going to follow your asymptote, and it's going to get closer and closer and closer to your asymptote, but it's never going to cross it. Over on this side, it's going to get closer and closer and closer to your asymptote, but it's never going to cross it. Now be careful, because some people are starting not to follow your asymptotes, and you're going to get minus points on your test. You have to make sure that you follow your asymptotes all the way through and beyond. On the top section, starting on your vertex, we are going to follow your asymptote, and it's going to get closer and closer and closer and closer, but not touching. On this side, I'm going to do the same thing. Make sure that you get closer and closer to your asymptote without going back. And now that I have my graph, now I can label my center. This is my vertex. This is my other vertex. Now we don't have co-vertices because those are not part of the graph. So therefore, what else do I need to find? I need to be able to find the value of C, because it will tell me how far it is from the the focus is away from the center. So I'm going to find C. So we have C squared is equal to A squared. There's a negative here, so therefore this will be positive. C squared is equal to A squared is 25. B squared is 9. C squared is equal to 34. So therefore take the square root on both sides. C is equal to the square root of 34. And we know the square root of 34 should be about 5.8. If we estimate it, 5.8, 5.9. So in this case, 5.8 should be fine. Now remember that your focus is 5.8 units from your center. So it'll be 1, 2, 3, 4, 5.8. And that'll be your focus. Your other focus will be 1, 2, 3, 4, 5.8. And your focus. Next, I need to be able to find the equation of your asymptotes. So therefore, see if you can find the equation of this line, and then we can compare it. Then find the equation of this line, and we can compare it. Go ahead and pause it. So find your asymptotes. You got it? So in this case, we are looking for an equation. It crosses out. Your y-intercept is 0, so therefore is b is 0. So therefore y equals plus 0. And my slope, I'm going to go from this point to this point. So I'm going to go from here to here. So it'll be 1, 2, 3, 4, 5, and over 3. So it'll be 5 over 3 in x. Now notice that in this case, to find the equation of this asymptote, once again, now the only difference that your slope is negative. So it'll be 1, 2, 3, 4, 5, 1, 2, 3. So what we do, we just say plus or minus. So therefore, your equation for your asymptote will be y equal to positive 5 over 3x and negative 5 over 3x. So let's write down on the line. So in this case, this will be your positive slope. So y equals 5 over 3x. And this will be your negative slope. So y equals negative 5 over 3x. Next, we need to be able to find our eccentricity. You need to be able to memorize your formula. So therefore, to find your E is equal to C over A. On hyperbola should be greater than 1. So therefore, E equals, the value of C was square root of 34. The value of A is 5. And we want to be able to change to a decimal because we want to make sure that it is greater than 1. And also we want to be able to find out, start to be able to figure out what happens as it's getting closer to 1 and what happens as it gets much bigger in this case. So in this case, we have the square root of 34 divided by 5. So therefore, that'll be 1.17. And you can give me 2 decimal places. And there's one more component I need to find. I need to be able to find my domain and my range. So let's go and find your domain and your range. So take a minute and see if you can find your domain and range, and we can compare afterwards. Pause it. Excellent. So in this case, your domain, we find a graph from left all the way up to the right. So therefore, your domain will be all real numbers or from negative infinity to positive infinity. Your range, we're going to go from the bottom. We start from negative infinity all the way up to negative 5. So from negative infinity all the way to positive 5. And 5 gets a bracket because 5 is included. Then we take a little gap. From -5, there's a gap all the way up to 5. So therefore, we're going to start once again at 5, all the way to positive infinity. And we said that is the union. So remember that on your homework, you want to make sure that you give me your asymptotes. You label them on the specific lines. Find your eccentricity. Find your foci and label your vertices, your center. And don't forget about your domain and range. So let's do one more graph together. Example number 2. And make a x and y axis. I need a 5 by 5. All of you guys should be using a ruler or your ID. So go through the process, find your center, find the value of A, B, find the value of C, graph it. But before, you need to decide whether your hyperbola is facing sideways or up and down. Correct. In this case, your x is first, it's positive. Just be careful because sometimes they'll flip them around. So it's not because it's first, it's because your x squared minus 1 squared, your x minus 1 squared is positive. So therefore, your hyperbola should be facing sideways. So go through the process and then we can check our work. Go ahead and pause it. Excellent. So at this point, you should have all your components. We know our center is going to be H is positive 1 and K is negative 2. So positive 1 and negative 2 is here. A squared is 16 and there's nothing underneath the y, so there will be 1, so therefore b squared will be 1. So therefore A is equal to 4 and B is equal to 1. So for my center, as under the x, there's a 16, so therefore, so 1, 2, 3, 4, sideways, 1, 2, 3, 4. Under the y, there's a 1, so I'm going to go up 1 and down 1. From there, we're going to make our boxes. So I'm just going to find my corners. And I'll make my box. The box is going to be dashed since it's only part of the construction, it's not part of the graph itself. I'm going to make my diagonals, which will be my asymptotes. I'm going to make it beyond the graph. Now I need to go to the side, sideways, so up and down. We decided that was sideways, so therefore make sure that you start at your vertex. You're gonna get closer and closer to your asymptote, but never touching it, always following closer and closer. Same thing here, you wanna get closer and closer to your asymptote, but never crossing it. From your vertex, you're gonna get closer and closer to your asymptotes. Remember that you cannot go sideways or just back up. You have to follow your asymptote all the way through. Now I need to be able to find the value of C. I'm going to use my formula, so therefore there's a minus here, so therefore my equation will have a plus. We know that we have A will be 4, but A squared is 16. B is 1, B squared is 1. So therefore C squared is equal to 17. C is equal to the square root of 17. And square root of 17 should be about 4.1. So therefore, it'll be inside your hyperbola. So I'll go 1, 2, 3, 4.1. place it right next to it. 1, 2, 3, 4.1. And let me go and label it. This is my focus. This is my vertex. This is my center. This is my vertex. That is my focus. Next, I need to be able to find the equations of my asymptotes. So for this, to find the equation of my asymptotes, I'm going to use my point slope form. So it will be y minus y1 equals m x minus x1. And I want to be able to find a point that I'm going to go through this line first. And I'm going to find, and notice that in this case, once again, they cross the same point. So I want to use the same point for both, which will be your center, which is 1, negative 2. So therefore it will be y minus negative 2 equals my slope, x minus negative 1, also minus 1. And notice that your slope, one of them will be positive, the other will be negative. So we're going to do both of them at the same time. And now to find my slope, I'm going to go from this point over to this point that we created. So it's going to be up 1 and to the right 4. And over here it was down 1 and to the right 4 for this one. So therefore 1 positive and 1 negative. And I just need to be able to simplify both equations. We have y plus 2 equals 1/4 x minus 1. And y plus 2 equals 1/4 x minus 1. So 1 positive and 1 negative. So from there, you want to make sure that you solve for y. Y equals 1/4 x minus 1/4 minus 2. So therefore y equals 1/4 x minus 5/2. In this case will be y plus 2 equals negative 1/4 x plus 1/4. Then move the 2 to the right, becomes a negative 2. So we have y equals negative 1/4 x. So 2/4, that gives me 8/4, so it'll be negative 7/4. Make sure that you place your slopes on your line. So therefore my positive slope, y equals 1/4 x minus 5/2. And my negative slope will be y equals negative 1/4 x minus 7/4. Remember, negative 7/4 is negative 1 and 1/3, and that's where it crosses. Negative 5/4 is negative 2.5, and that's where it should cross. So this one doesn't look right. Yeah, did you guys catch my mistake? It should be 1/4 here. So therefore there'll be negative, that's 9/4. So you can fix that, that should be negative 9/4. And now it makes a little more sense. Because this is negative 2 and 1/4, negative 2 and 1/4, that looks fine. And the last thing I need to do, I need to be able to find my domain and range. So therefore my domain is from negative infinity all the way up to negative 3. And then we start again at 1, 2, 3, 4, 5, at negative 5 all the way to positive infinity. Negative 5 also gets a bracket, and we'll say that's the union. The range will be all real numbers. We find a graph all throughout any value of y. So it'll be negative infinity to positive infinity. So remember that for your homework, you want to make sure that you find your center, find your asymptotes, and don't forget to confirm that those match the lines that you have. Find your domain and range. And what else am I missing? I'm missing my eccentricity. So therefore, my eccentricity, you have to memorize your equation, E equal to C over A. For a hyperbola, I should give you a value bigger than 1. So C E equals, the value of C in this case was square of 17, and the value of A was 4. And for purposes, we do need to be able to change it to a decimal. So it should be very close to 1. So we have square of 17 divided by 4. And 1 is a decimal, so it gives you 1.03. So notice that as your hyperbola gets thinner and thinner, then this will be 1. And one of the things that you notice as it opens up more and more, this will be greater than 1. But we'll look at the eccentricity next time I'll see you. Example number 3. Go and copy it down, and then we can work on it together. Make sure, in this case, so go ahead and pass it, write down, and then make a sketch and see if you can actually figure out the equation. And I'll give you guys a few minutes. Go and pass it, make a sketch, see if you can figure out the hyperbola, the equation of the hyperbola. Go and pass it. Excellent. So in this case, it's they give you 2 vertices, and they also give you the asymptote. So I'm just going to make a quick sketch. So therefore we have 3 and 2, and 2, 4, 6, 8, 9. I need a little more space. So therefore, so what's the difference between this point and this point? We have, this is 3 and 2. And this is 9. So therefore the midpoint between 3 and 9 will be 6. So therefore that'll be my center. So therefore my center will be at 6, 2. My center will be at 6 and 2. Now notice that since your vertices are, both of them are up 2, then that's going to be a horizontal major axis, which means that my hyperbola has to be facing this way, so sideways. So therefore I'm going to place my x first. So my equation will be x squared minus y squared equals 1. My center is -6 and -2. Then to the left is 3 spaces, so therefore it will be 9. I need to be able to figure out how much I have to go up and down. So the only other information that I have are my asymptotes. My asymptotes is -2, and to the right 2 and over 3, to the right 2 and over 3. So notice that this matches. So this will be my asymptote. Then on this side, my y-intercept is 6. My slope is down to the right 3. So therefore this will be my from there we can deduct that we went up 2 to make this box. So if I go up 2, therefore this will be 4. Something else that you can actually tell, notice that in this case, your slope is y over x. Under the y, there's a 2 square, so it'll be 2. Under the x, there'll be a 3 square, so it'll be 3. So therefore, this is the equation of a hyperbola that has vertices 3 and 2, 9 and 2, and meets this requirement. And the last example for today. Example number 4. So we just need to be able to rewrite it in standard form. So take a minute to write it down. So very similar to before. So we're going to group your x's together, leave some space, group your y's together, leave some space, and move the 4 to the right. So we have negative 4x squared plus 8x, leave some space, and that will give me a 4. So therefore, see if you can complete the square on both, and then we can check our answers. Give you guys a minute or two. Go and pause it. Excellent. So in this case, I'm going to take out my common factor, gives me a negative 4. And what is left behind, we have x squared plus 2x. And that should be a minus 2x, correct? Negative and positive. And half of negative 2 is negative 1. Squared gives me a positive 1. Multiply it out, gives me a negative 4. So therefore, we need to subtract 4 on both sides. In here, I don't need to factor anything out. So therefore, I can just complete the square. Half of negative 4 is negative 2. Squared gives me positive 4. And I added 4, so I need to add 4. That's 0, that's 4. I'm going to factor this out, so it gives me negative 4. X minus 1 and x minus 1, x minus 1 squared. Y minus 2 and y minus 2 will be y minus 2 squared equal to 4. Then divide by 4, divide by 4, divide by 4. So it gives me a negative x minus 1 squared plus y minus 2 squared over 4 equals 1. Now, we prefer to write down my positive 1 first. Now, sometimes you guys will see it in this form where this will be facing sideways or up and down. What do you think? Correct. This is going to be facing up and down. So ideally, I need to be able to rewrite it as y minus 2 squared over 4 minus x minus 1 squared equals 1. Homework is online, and I'll see you guys next time. Have a great day.